December 2025 arrived in Europe with a quiet, persistent chill. Subtle, yet widespread. It wasn't the dramatic freeze of legend, but a gentle coolness that stretched from Scotland to the Mediterranean, defying forecasts. This anomaly, first noticed on December 3rd, invites us to explore the delicate balance of Europe's climate and what happens when it's nudged off course. Across London, Paris, and even Rome, people felt a cold that seemed out of place for early December. These shared experiences reveal a continent-wide climatic curiosity, a puzzle worth unraveling. For decades, Europe's story has been one of warming, retreating glaciers, rising seas, intensifying heat waves. So when a region so central to global climate trends cools unexpectedly, it forces us to ask, is this a random blip or a sign of deeper changes? Let's dive into the mystery of Europe's gentle December shiver. To understand the anomaly, we must first know what's normal for a European December. Typically, the Atlantic's influence brings mild, damp winters to the west, rainy, not snowy, with temperatures above freezing. Inland, cities like Berlin and Warsaw expect the first real frosts, with snow dusting the landscape and temperatures dipping below zero at night. The Mediterranean south enjoys cool but pleasant days, rain replenishing the land, and outdoor life continuing with just a light jacket. All of this is orchestrated by the jet stream, which usually steers mild, wet weather across the continent. Its stable path is the backbone of Europe's winter forecasts. The expected December is a season of gradual change, not surprises. But in 2025, the script was rewritten. On December 3rd, weather stations across Europe reported a subtle but persistent deviation from the norm. London's temperatures hovered around 5 degrees, 3 below average, while Paris saw highs of just 2 degrees, with sharp frosts. Berlin and Munich barely rose above freezing, and even Rome and Madrid felt a chill, with highs stuck near 10 degrees. The Mediterranean, usually immune, was caught in the grip of this gentle coolness. High atmospheric pressure dominated northern and central Europe, diverting the jet stream and keeping skies clear but cold. The result, bright, sunny days that offered little warmth and a continent-wide quiet chill. This wasn't a dramatic cold snap, but a widespread, persistent suppression of temperature. The data pointed to a larger atmospheric puzzle. The winter Europe expected was mild and familiar, rainy days, gradual cooling, and outdoor life continuing with minor adjustments. Instead, a crisp, dry cold arrived abruptly, with clear skies and penetrating chill. Central Europe felt late January's bite in early December, forcing people to adapt quickly. For farmers, the sudden cold and dry weather stressed autumn crops, highlighting how dependent agriculture is on predictable seasons. The atmosphere itself was transformed. Instead of blustery Atlantic winds, a profound stillness settled in. The blocking high-pressure system created calm, stagnant air, making the cold feel pervasive and inescapable. This quiet deviation from the norm is a key clue to the planetary mechanics at play. The difference was subtle, but its implications were significant. Europe's winter had shifted from the expected to the extraordinary. The culprit behind Europe's chill was an atmospheric blocking high, a stubborn, high-pressure system anchored over the North Atlantic and Northern Europe. This block diverted the jet stream, keeping mild Atlantic air at bay and letting cold Arctic air drift south. Such blocks form when planetary scale waves, called Rossby waves, become amplified and break, creating stagnant pressure systems. Arctic changes, like rapid sea ice loss, may be making these blocks more common by destabilizing the jet stream. The stratospheric polar vortex, when weakened, can also nudge the jet stream into a blocked, colder pattern. Cooler than average sea surface temperatures in the North Atlantic can reinforce these high-pressure systems. The result, a feedback loop where small changes in one part of the Earth trigger widespread weather shifts. Europe's December chill was a product of this intricate atmospheric dance. A few days of cool weather might seem minor, but as part of a trend, it's significant. More frequent blocking patterns could mean not just winter chills, but also summer heat waves and droughts. Global warming isn't a simple, steady rise in temperature. It's a reshaping of weather patterns, leading to more extremes. A cooling anomaly doesn't disprove climate change. It may be a direct result of Arctic warming. Disrupted seasonal rhythms can stress crops, wildlife, and energy systems. Early frosts can damage plants, while stagnant cold spells challenge energy grids, especially as we shift to renewables. Predictability is key for agriculture, ecosystems, and infrastructure. As these patterns become more common, resilience and adaptation will be crucial. Europe's gentle chill is a warning. Climate change brings surprises. Subtle shifts in weather are more than curiosities. They're signals of deeper change. Our societies are built on the assumption of stable seasons. When that stability wavers, everything is affected. Studying anomalies like Europe's December chill helps refine climate models and improve forecasts. Every unexpected event is a real-world experiment, offering data to guide adaptation. For farmers, city planners, and individuals, understanding these shifts is vital for making informed decisions. Weather is the voice of a changing planet, speaking in patterns and anomalies. Listening to these whispers fosters awareness and responsibility. The gentle chill of December 2025 was a message. Pay attention to the quiet signs of change. December 2025's blocking pattern brought a gentle but widespread cooling to Europe, defying expectations. This event, while not extreme, is a case study in the complex effects of a changing climate. As the Arctic warms, the jet stream grows more erratic, making stuck weather patterns, cold snaps or heat waves, more likely. The future may bring more weather whiplash, with longer periods of extremes. Building resilience into agriculture, energy, and cities is essential. Global warming is not linear. It's a complex restructuring with unpredictable regional effects. Cooling in one region doesn't contradict global warming. It illustrates its complexity. Navigating this new reality requires foresight, adaptation, and a commitment to understanding the planet's signals. Europe's gentle December chill is a story of connection, linking Arctic ice ocean temperatures and daily life across the continent. It reminds us that our climate is a single, interconnected system where distant changes ripple across the globe. This event wasn't a disaster, but a message delivered in the language of weather. The climate isn't a simple machine. It's a living, complex system responding to our actions. Regional cooling amidst global warming is a paradox we must learn from, not ignore. By paying attention to small anomalies, we become active participants in our planet's story. Let's see these events as lessons in complexity and invitations to listen more closely. Our future depends on heeding these subtle messages, with wisdom, humility, and a renewed commitment to balance.